All right. Hi guys. We are going to be attempting this online CPM help / support with your lessons. So this is going to be 7th grade, the first lesson that I assigned for the break, and it is 6.1.4, and it's titled, How Can I Find All Solutions? So at any time you can pause the video, you can zoom in to see, because I know it's kind of hard to see, and maybe on the next few videos I can adjust the zooming and everything. But if I'm looking over there, I'm looking at my textbook and reading it. If I'm looking over here, I'm looking at my work that I've already done. So if you see me looking one way or the other, that's why. We also have my dog Bailey in the background, and she's going to be here for moral support as well. Okay, so let's get started. 6.1.4, how can I find all solutions solving one variable inequalities? Okay, so remember, a variable is a letter that you substitute in for a number. And an inequality is just a less than or equal to, greater than or equal to. Okay, so remember those, the alligators eating the bigger number. Okay, so we're gonna describe a process today to help us solve linear inequalities. So 6-35 says, and I'm gonna find my eraser, there we go. So 635 is our first problem. We're gonna get through 635 through 639 today. So 635 starts off with, Jerry and Ken were working on solving the inequality, and I'm going to write this down, 3x minus 1 is less than or equal to 2x. They found the boundary point, and Ken made the number line graph shown at right. So in your book or on your e-text for CPM, they show you a number line, and it looks somewhat like this. So it's got 1, 2, 3, 4, -1, -2, -3, and -4. And then it has a open circle on number 1, and then it has a bold line going to the left with an arrow. So Jerry is noticing a problem. He says, doesn't the line at the bottom of the less than equal to symbol mean that it includes the equal part? That means that x equals 1 is also a solution. How could we show that? Jerry said, well, the solution x equals 1 would look like this on a number line. So then he does this. He shades in the circle so that 1 is included in the solution set. And then he says, is there a way that we can combine the two number lines, which I kind of just did. So I just shaded in that dot up above 1 to show that 1 is also included in the solution set. Okay, so it says to discuss the idea with your team and be prepared to share your ideas. So this was kind of a simple, this is the answer type thing for this problem for 635. So this would be the final answer to show that x equals 1 is also a part of these solution sets. Okay? Let's move on to 636. If you need to pause, you can do that and you can look at it. But I don't need to pause, I guess. I'm just going to start erasing. All right, moving on to 636. I'm just going to double check and make sure that it's still filming. Don't do what I just did. Okay, 6-36. Okay, so now if you look in your book, it's going to show you a diagram that looks like this. It says words, it says graph, and it says symbols. I'm trying to write this as best as I can. And then it has arrows going to each one. So it says review the meanings of the inequality symbols, greater than, less than, greater than or equal to, and less than or equal to. So we know what those mean. So this is, greater than, less than, greater or equal to, less than or equal to. Okay, if you want to pause there to write that down, you can. Now it wants us to generate the two missing representations. So here's our representations from each inequality described in parts A through C. So we're going to do that now. So we're going to kind of, what was it that we did? We did the, there was a, never mind. We'll get into that later. So I'm going to erase this, and we're going to look at A. So A says, X is less than negative 1 1/2. Sorry, I'm trying not to get it too smushed. So we've got the symbols. Symbols is covered. Check. Now we need to draw a graph and write what we see in words. So I'm going to do the words part first because that's going to be easiest. I'm literally going to write how I would say this out loud. So X is less than negative 1 1/2. So that would be your first part for A. And if at any time you want to try these out without me like saying the answer already, pause the video and then you can try it out and then watch for the answer after I'm done. Okay, so then we've done our words. So now the last thing we need to do for A is build a graph. And by graph, they just want you to do like a number line. And I'm going to start at 0 in the middle. And then I'm going to make some dashes. These are the negatives. These are positives. And just for the sake of time, I'm not going to write the numbers underneath, but I'm going by ones every time. So for some, I'll write the numbers underneath. -1, -2, -3. So I know that my boundary point is -1 1/2. So my point is going to lie right in between -2 and -1. And since it does not have a line underneath the inequality, this dot is going to be open. It's not going to be closed. If this had a line under it, then I would close up the dot. But since it does not have a line under it, sorry, now it's all stained, it looks like that, open dot. So now I need to represent how it is, X has to be less than -1 1/2. So what I did is I thought, well, X has to be everything this way. It has to be less than. So I did a bold line and then I just put an arrow and that shows the graph for X is less than -1 1/2. If we went this way with our line, that would mean that X would be greater than -1 1/2. Okay, so you can pause there, but I'm going to erase it. And we're going to move on to B. Okay. B says, B gives us the words first. So they give us these words. X is greater than or equal to 2. Okay, so it gave us the words, check. Now the last two things we need to do is draw a graph and write it as symbols, which just kind of means you write it with variables and numbers. So let's write it with symbols first. You can do it right now if you want to pause it and try it out. But I'm going to get right into it. So X is what we're going to put on our left side of the inequality. Greater than or equal to looks like this. And then our last part is the number 2. So that is what our symbols would look like. The last thing we have to do is do a graph. And this should be pretty simple. Another number line. And that's supposed to be where 0 is. So I'm going to locate my boundary point, which is 2. And I'm going to say, okay, there's 1, there's 2. This time I have a line underneath the inequality. So I am going to make it a closed dot. That means 2 is included with the solution set. And then if x has to be greater than 2, I know my solutions have to be everything to the right of 2. So I'm going to shade in a big bold line. And an arrow means it goes on forever to the right. Okay, so you can pause there if you need to. I'm moving on to C. Okay. Part C says, Part C gives us a number line. And the number line looks like this. And it's got 1, 2, 3, 4. And then it's going 1, 2, 3, 4, 5. -1, -2. Sorry, that does not look good. Okay, and then it has a closed dot on the number 2. And it has a bold line going all to the left with an arrow. So now we have the graph for this one. Sorry, I need to put C. There we go. We're still on 636. So this is part C. We need to write this in words, and we need to write it as an inequality. So let's write it in words first. So we're going to say x, because that's always going to be our variable here. X is, and I'm going to say that since I know it's all going to the left, x has to be less than, because it's going towards the lower numbers. So less than, and then I'm going to think to myself, okay, is it going to be just less than, or is it going to be less than or equal to? And I'm going to notice my dot, if it's closed or open, and it's closed. So if it's closed, that means it's or equal to. And what number are we using? 2. So we did our words, we did our graph. The last thing we have to do is our symbols, and that should be pretty easy because we're just going to write what we see here in symbol form or variable form. So x is less than or equal to 2 is going to look like x is less than or equal to 2. And that is 6-36 part C. So we have finished 636, and we are going to move right along. Again, you can pause it whenever you need to write stuff down. All right, 637. We're halfway through almost, yay! Okay, 637 says, when is the boundary point included? So for parts A, B, and C, it says to represent the solution for each of the variables described below as an inequality on a number line and with symbols. Okay, so we're gonna have to graph it and write an inequality for each A, B, and C. So here's A, and I'm gonna read it. The speed limit on certain freeways is 65 miles per hour. Let X represent any speed that could get a speeding ticket. So I was thinking to myself, okay, our boundary point number is 65. And to write it as an inequality, I need a variable. So I'm going to put my variable here. So the speed limit is 65 miles per hour. So if I'm driving 65 miles per hour, I'm safe, I'm good. But anything above 65 miles per hour is going to get me a speeding ticket. So I wrote my inequality like this. If X, your speed limit, is greater than 65, you're getting a speeding ticket. So I did not include a line underneath the inequality because that would include the number 65. So if I was going 65 miles per hour on the freeway, I could also get a ticket. But that's not the case for what the words are saying. They're saying if you go above 65, you're getting a ticket. So that's going to be our symbols. And on the number line, I kind of did these kind of quickly because I didn't want to write out 65 in ones, you know, like 1, 2, 3, 4, 5, 6, 7, all the way to 65. So I picked a number that would be easier to work with. So I did 20s. So I counted by 20s, 20, 40, 60, 80. Okay, and to graph it, I kind of went in between 60 and 80. And I know that it's going to be open dot, because there is no line underneath the inequality symbol. So I'm gonna go right here, right there's good. Now, my bold line is gonna be everything to the right of 65, because everything above 65 will get you a speeding ticket, possibly. And that is part A. All right, you can pause there if you need to. I'm gonna move on to B. So B says, let me just double check and make sure it's still recording. Okay, good. Okay, B says, you brought $10 to the mall. Let Y, so now we're using the variable Y, let Y represent any amount of money that you can spend. So I knew my boundary point was 10, so I brought 10 to the mall. Now my variable is Y this time, so we're using a Y. And then I can spend anything that is $10, so I can spend $10 or anything less than that. So I put Y has to be less than or equal to, because you can spend $10. It didn't give you like, oh, you can't spend $10, you have to spend less than $10. It said, you brought $10 to the mall, and let Y represent any amount of money you can spend. So we're gonna include 10 with our inequality here. So now once again, we're doing a graph. I'm gonna do it by twos, 2, 4, 6, 8, 10. And then my boundary point is 10, and it's gonna be a closed dot because it is less than or equal to 10. And then I'm going to make a bold line all the way down to 0. Now some of you might say, well, you can't spend a negative amount of money. Like you can't spend like -$1, I guess, at the mall. If you would like to write it like this, you can. Some people may want to write it as a 0 is less than or equal to Y, and Y is less than or equal to 10. So this kind of shows you that it has to be between 0 and 10. So 0 has to be less than Y, and Y has to be less than or equal to 10. So some people might write it that way, but you can stick with this first one. Okay, so that's part B. And part C, to ride your favorite roller coaster, you must be at least 5 feet tall, but less than 7 feet tall. So let H represent any height that can ride the roller coaster. So we have kind of a limit here. So I'm gonna have H, and we are gonna write like the inequality symbol, and then a number here and a number here. Let's start with our H. So that's our height, and you have to be at least 5 feet tall, but less than 7. So I'm gonna start with that less than 7. So your height has to be less than 7, and it didn't say equal to 7, it said less than. So if you're 7 feet tall, you can't ride. And then you have to be at least 5 feet tall. So 5 feet is gonna be included here. So I am going to put a less than or equal to 5. So this just means that 5 is going to be your boundary point, and 7 is going to be your boundary point. So there's 2 boundary points here. And to graph it, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is how I graphed it. I found my first boundary point, which is 7, and I put an open dot because there is no greater than or equal to, less than or equal to, underneath that inequality. And then I put a closed dot on 5 because you can be 5 feet, that's included. And then I just put a bold line in between. Because if you're below 5 feet, you can't ride. If you're 7 feet or above, you can't ride. So we have a very small set of people who can ride this ride. Okay. That is 637. Let's move on to 638, and we're almost done here. I know I already said that, but I promise we're almost done. Okay, 6:38. Ellie was still working on her dollhouse. I think we had this in a different problem, but she's still working on it. She has boards, 6:38. She has boards that are 2 different lengths. One long board is 54 inches. Part A says, the length of the short board is unknown. So Ellie put 3 short boards end to end and then added her 12-inch ruler end to end. The total length was still less than the 54-inch board. Draw a picture showing how the short and long boards are related. That's a lot of words, so we're going to go with what we know so far. We know one long board is 54 inches, and it's telling us to draw a picture. So I'm going to draw a picture of a long board, which is 54 inches. But we don't know the short boards. But she put 3 of them. She lined them up, and I'm just going to put them like this, and I'm trying to make them equal here. That's not very equal, but pretend like those are equal lengths. And then she put her ruler end to end, and the total length was still less than the 54-inch board. So here's what I'm going to do first. Yeah, that's good. No, that's good for A. That's good for A. Let's move on to B. That's our picture. Now it says, write an inequality that represents the relationship between the short boards and the 54 inches shown in your diagram. And the wording's kind of weird here. So Ellie put 3 short boards end to end and then added her 12-inch ruler end to end. The total length was still less. Okay, so she had a ruler here. Okay, so she had a 12-inch ruler that was still off the end of that one. Okay. Yes. We're going to write an inequality. So we know we have 3 short boards, and I'm going to label them as X's. And we have 3 of them, so you can write them as 3X, which just means 3 times X. And then we're going to add that little 12 at the end. And then we know that it's less than 54 inches. So I'm going to write my less than symbol with the number 54. Okay, that is going to be what our part B is. And it does say to state what your variable represents. So our variable here represents the length of short board. Okay, so 3 short boards plus 12 is still less than 54 inches. So it says part C, what are possible lengths of the board? So what I did, I kind of wanted to solve it. So I took away 12 from both sides. So I treated this as like an equal sign. So I pretended that this was an equal sign, and I wanted to get rid of the 12s because I want X to be by itself on this side so I can solve for X. So those 12s go away. We're left with this 3X is less than 42. And then if we divide both sides by 3, we will get X all by itself. And 3 into 42 is 14. So X has to be less than 14. Because if it was 14, it would equal 54. But you can't do that because it has to be less than 14. Remember, this means less than. So X is less than 14. It wants you to show it on a number line, and I'm going to do it up here real quick. Here's 0, 1, 2, 3, 4, 5, 6. Divided by 2 is 2, 4, 6, 8, 10, 12, 14. So I'm going to write my open dot on 14 because we're not including 14. And then everything below 14 would work for the board. And once again, some of you might say, oh, well, the board can't be a negative number, so 0 would be your ending point, and you could put a 0 there. 0 is less than X, and X is less than 14, to make that in between 0 and 14. Whew. All right, one more problem. One more problem. 6:39. Bailey's snoring over there. 6:39. Jordan, Terry, Morgan are gonna have a kite flying contest. Jordan and Terry each have 1 roll of kite string. They also each have 45 yards of extra string. Morgan has 3 rolls of kite string plus 10 yards of extra string. All of the rolls of string are the same length. The girls want to see who can fly their kite the highest. That just gave me a whole lot of information, and I really need to organize my thoughts right now because that was way too much stuff to think about. So here's what I did when I first tried this problem. I wrote down each girl. So I knew Jay, who's Jordan, she has 1 roll plus 45 more yards of string. So for rolls, I used the variable x. So she has 1x, 1 roll, plus 45 extra yards. And then Terry, is it Terry? Yeah, had the same thing, I believe. Yes, Terry had the same thing, 1 roll plus 45 extra. And then Morgan had different ones. She had 3 rolls. So I'm gonna write a 3 in front of my x to show that I have 3 of those x's plus 10 extra yards. Okay, so now I've kind of organized my thoughts a little bit more. I'm gonna put x equals roll of string. Okay, so part A says, since Jordan and Terry have fewer rolls of kite string, they decide to tie their string together so their kite can fly higher. Write at least 2 expressions to show how much kite string Jordan and Terry have. Let x represent the number of yards of string on 1 roll. So all we're doing here, it's a lot of information again, it's just asking you to write 2 different expressions, so an equation but without an equal sign, to show how much kite string they have if they put it together. So if I want to put their string together, I'm just going to write both of their expressions and combine them. So I'm combining x plus 45 plus x plus 45. Now that I have this, that could actually count as one of your expressions. If I want to write another expression that is equal to the same thing, I could just combine like terms. So I see how many x's? I see 2 x's. And how many ones? I'm going to combine my 45 and my 45. 45 plus 45 is 90. So there is the expression, the 2 expressions for part A. So now for part B, it says write an expression to show how much kite string Morgan has. Again, let x be the number of yards of string on 1 roll. So we kind of already did that when we were writing down our thoughts at the beginning of the problem. See, Morgan is equal to 3x plus 10. So that's all you have to write for B. That's Morgan's expression. She has 3 rolls of string plus 10 extra yards. Now for part C, how long does a roll of string have to be for Jordan and Terry to be able to fly their kite higher than Morgan's kite? Show your answer as an inequality and on a number line. In order to do this, I set both expressions. I used it as an inequality. So I started out with theirs, Jordan and Terry, 2x plus 90. And then it says they want to fly it higher than Morgan's kite. So I put a greater than symbol because whatever this is, if we solve for x, needs to be greater than whatever Morgan's is. So there is our equation that we're going to solve. So here's our inequality. Now it says, oh, okay. We're going to solve this. So what I want is the x's need to be on one side and the ones need to be on the other side. In order to do this, I see I can move this 2x by subtracting a 2x from itself and then subtracting a 2x from the 3x. So that becomes 0. This comes down, and it's 90 is greater than 3x minus 2x just gives you 1x plus 10. Now you can kind of figure out what it might be from here, but if you wanted to really be precise, you could move this 10 to this side by subtracting it, because we want it to be 0. And now I'm left with 80 is greater than x. Hopefully you can still see that. Okay, good. So 80 would have to be greater than x. So that means x is, if we wanted x on this side, it would be x is less than 80. So notice how if you want to switch this x over here, you have to flip the inequality symbol the opposite way to flip the numbers. Okay? So x has to be less than 80 for, for Jordan and Terry to be able to fly their kite higher than Morgan. I am going to start erasing some stuff. I'm going to erase this stuff up here because we're going to move on to, I'm supposed to do it on a number line. Okay, I'll do a quick number line here to show x is less than 80. Let's do 0, 20, 40, 60, 80. So if x is less than 80, find our 80, put an open dot because it cannot include 80. There's no equal to sign, and x has to be less than. So I'm going to do all those numbers below 80. Okay. Part D. How long does a roll of string have to be for Morgan to be able to fly her kite higher than Jordan and Terry's kite? Show your answer as an inequality and on a number line. So for this one, here's my inequality. 3x plus 10 has to be greater than their 2x plus 90 that we had before. So once again, I'm going to move this 2x over, so I want x all by itself on one side. X plus 10 is greater than 90, and you'll notice that we're going to get the same answer as before, but reversed this time. So if Morgan wants to fly her kite higher, she needs to have 80 yards for each roll. Sorry, 81 or more, because 80 is not included. So here would be our number line. 0, 24, 60, there's 80. So this one would be an open dot and everything to the right of 80. Whew. For part E, it says, what length would the roll of string have to be for the girls' kites to fly at the same height? It would have to be 80, because if we plugged in 80 here and 80 here, they would be equal, and if they would be flying at the same height. So I'm going to put part E right here. X would have to equal 80. Okay, that was kind of a lot. And I'm going to stop there because that is the last problem we had to do. If you have any questions, you can text me, you can email me, you can call me, and I'll answer some questions about this lesson. But that is it for 6.1.4, and I'll see ya in the next one.